Greetings and salam sejahtera. My name is Sarvess Ganesan, registration number 01DAD20F1015. My group mates are Muhammad Lutfi Hadi bin Nizam, 01DAD20F1027, and Ahmad Naquiddin bin Muhammad, 01DAD20F1014. My project supervisor is Encik Adi Firdaus bin Hat. For our Project 1 proposal, we have decided to do our project entitled Portable Mini Drainage Hydro Station. And we are Group 4, and this is our Project 1 proposal. I will start with the background of our project. The world is facing an energy crisis where the demand for energy commodities exceeds supply and demand, and this is causing volatility in short-term pricing, with the global spot prices for natural gas reaching the highest level this year. Most of Malaysia's electricity generation capacity is natural gas fired and by coal, but the government is seeking to achieve a more balanced portfolio of electricity generation over the coming years to meet its growing demand and reduce its dependency on fossil fuels. Hydropower technology is very important to generate energy. We conducted this study to find the possibility of generating energy sources from small water areas such as drains and ditches. Nevertheless, this study will focus on ways to study and design mini hydro stations that can be installed in small or medium-sized drainage facilities and systems. The project will develop a portable electricity generating machine for the use of small drains, and this mini electric power generating machine is an innovation from the electric generators found in dams today. The concept is efficiently adapted and improvised into functionality and using for drainage systems, specifically focused in Polytechnic Ungku Uma drainage system. This hydro station uses a turbine which will be installed and connected to an energy generator. This hydro station uses water flow to rotate the turbine, which in turn then turns the electric generator. The same concept will be used in the mini hydro station, where the water flow from the drain rotates the turbine, hence rotating the electric generator and producing electricity. Every project begins with the idea of solving a problem, and so did we. One pivotal problem we wanted to solve or find ways to overcome is the current energy crisis. 65% of the global energy produced is from fossil fuels such as petroleum and natural gases. The demand and need for global energy are ever increasing as the years go. But our current primary resource is depleting fast. Even the most conservative industry insiders believe that we could run out of oil within the next 50 years. A study by Chariot Energy from Chariot University states in a 2015 research that there are enough oil to sustain the global energy consumption for about 50 years based on a reserves to product RP ratio, which measures the years of production left based on the known reserves and annual production levels. On the other hand, the natural gases that are obtained will provide the world with energy for another 53 years. Another recent research by Octopus Energy generally estimates that we will run out of fossil fuel, mainly oil and natural gas, by the year 2060, which is in 38 years if we keep burning fossil fuels at our current rate. So the problem this project wants or needs to find a solution or to solve is to find ways to overcome and implement. Another problem this project aims to solve is accessibility and mobility. Almost all hydro stations are built from the ground on one place, as they commonly use water flow from a dam or wide rivers. They are built and reinforced to withstand the force of the high pressured water flow. This project focuses on low medium flow of water and in drainage systems. This project hydro station aims to solve the mobility problem by making the whole hydro station portable, where the hydro station is already fixed and then just arranged and aligned to the size, location and position in PUO drainage system. This position can be changed and the height increases as the water level rises. The problem we are truly looking forward into solving is the mobility and ability to adjust height and position of the hydro station. Now, besides oil and natural gas, there's another source of energy production, which are coal. There are enough coal reserves to last the next 150 years, which is 2+ generations of materials we can burn to create the electricity needed. But do not forget a primary factor, which is coal is the most environmentally harmful fossil fuel in terms of burning and extracting. That brings me to the second problem statement, that is and has been one of the bigger and more important problems to solve, which is global warming and climate change. As greenhouse gas emissions blanket the earth, they trap the sun's heat. This leads to global warming and climate change. The world now is warming faster than at any point in recorded history, with evidence of the rise in water level, melting of icebergs in equator. Even us currently in Malaysia, we have recently experienced unstable heat and rainy season. Sometimes during the day it is so hot, but towards the night it's raining so heavily, which now leads to the drought season and the multiple flood cases in KL primarily. This is one sign of the current climate change that we must look into. Now, as I've said, this signifies the importance and urgency to find and implement greener, cleaner, and a more sustainable way of generating energy. This project solves one part of the puzzle by doing a research on generating green energy by designing and building a portable hydro station, which will be tested and data collected in PUO drainage system. The main objective of this project is to study and design a mini hydro station that can be installed in a medium or small size drain. This project also aims to find a possible solution to global warming and climate change by studying and calculating the energy produced in a hydro station, to then further study if it produces enough energy to be introduced and developed better to other places or in a bigger scale to generate cleaner, safer and sustainable energy by using low medium flow of water in a drainage system. This project also aims to study the efficiency of turbine under a low medium flow of water, as most traditional hydro stations require high flow of water to push the blades of the turbine, hence producing electricity. This project focuses on collecting data from the hydro station, mainly the current and energy produced. At the same time, it is also targeted to study all other important items that are needed to help build the foundation of this research.
Hello, my name is Muhammad Lutfi Hadi and my matrix number is 01DAD4A1027. So next, for the survey result and product improvement. This project research was done quantitatively through a survey created using Google Form. So this survey was shared to public through social media such as WhatsApp and Instagram. And also the survey was circulated for 3 weeks and the survey data was collected in a spreadsheet. And the survey aims to fulfill consumer needs and resolve several state problems. Okay, the questionnaire approach was used as a study tool to collect data. The selection of respondents consists of Polytechnic Oklahoma, student and public. The questionnaire received good feedback and was answered by people of all age. And the survey that was created used the Likert 5 scale. So 1 means that not aware and 5 means that very aware. So for some question, brainstorming was also done to find solution to the problem and limitation that we are trying to overcome. So the question that we use is, what is your name? For the second question is, are you aware of the current climate issues? Third, do you know the based on sea level projection for 2050? Then to bring the scape down further, do you realize that most part of Bagan Datuk, Kuala Selangor, Kinchan and even most part of Kelang will be underwater when the level rise due to arrogance to climate change? And the fifth question, do you know about the generation of electricity through the method of hydro station today? Next, the usage of hydro station to generate electricity. And for the seventh question, in your opinion, can this portable hydro station play a part of one of the solutions to solve the current climate problem and energy crisis now? Next, do you think it is impossible or possible to implement this idea in Polytechnic Oklahoma facility and be used as a source of energy generator? Then the ninth question, justify your answer for the question above. And the last question, in your opinion, what could be done differently in the project design?
Now, for the survey questions, one main question that we would like to highlight is, do you know about the generation of electricity through the method of hydro stations today? And out of 20 responses, 70% said yes, 20% said maybe, and only 10% said no. What we can deduce from this results is that people are aware of the production of electricity through the methods of hydro station. Another question that we should look into is, in your opinion, can this portable hydro station play a part as one of the solutions to the current climate change problem and energy crisis? Out of 20 responses, 50% said yes and 50% said maybe, and no one said no. What this shows is that people do know about the current energy crisis and people are aware, as they said 50% for yes and 50% for maybe. In this context, maybe means they know but they're just unsure. So this is a prominent result, a important aspect for this project to move forward, as people know and they are aware. Now, another question that was raised was that, do you think it is possible to implement this idea in Polytechnic Oklahoma drainage system and be used as a source of energy generator? Now, for this, 65% said yes and 30% said no, and 30% said maybe, and only 5% said no. What this shows is that people believe that this project can be implemented in Polytechnic Oklahoma and be used as a source of energy generator.
Okay, so for house quality, we have divide the scoring into the 3 parts. First, we have strong, it is 9 point, moderate, it is 3 point, weak, and it is 1 point. So for the turbine effectiveness, for the size, we have moderate, cost moderate, power output strong, generator moderate, and dimension is strong. The next one is durability. For the size is weak, cost is moderate, power output strong, generator strong and dimension is moderate. Next is mobility and portability. For the size, we decide to strong, cost moderate, power output weak, generator weak, and dimension is strong. 4 is ability to float. For the size, we have strong, cost we have weak, power output we have moderate, generator we have a moderate, and dimension we have strong. So for the last one, electrical and environment safety. For the size, we have weak, cost we have moderate, power output also moderate, generator is strong, and dimension is weak. So for the total, for the size, we have 21 point, cost we have 12 point, power output we have 24 point, generator we have 21 point, and dimension we have 30 point. Order and order. Dimension have 1 rank, generator and size has 3 rank, power output have 2 rank, and cost we have 4 rank.
So next is the brainstorming for our concept generation. So this project is a portable mini drainage hydro station, and we have 3 main points, that is effective, mobility, and space saving. So for the effective, we have effective turbine design, and for the mechanism we have it give output, and also it generate electricity energy. So for the second point is mobility. So this project is a portable project, and this project also is also so light. One of the material that we use is PVC. And for the third point is space saving, and the mechanism we are used in this project is a lot smaller or in a smaller scale.
Okay, for a morphological chart, we have 3 concepts and 6 parts to choose. First concept, frame body, we use option 4. For a turbine, we use option 3. For a connector, we use option 2. For a electrical control circuit, we use option 3. And for a connector, we use option 2. And a bearing, we use option 1. The next part is concept 2. Frame body for concept 2, we also use option 4, but in turbine we use first option. For a generator, we use option 2. For a electrical control circuit, we use option 4, and for a connector, we use option 2, and for a bearing, we use option 1. The last concept is concept 3. In concept 3, frame body, we use option 2. Turbine, we use option 2. And generator, we use option 3. And electrical control circuit, we use option 2. And connector, we use option 2. And the last part is bearing. Also, we use option 1.
Next, this is a concept design while sketching. That is my design. Next, this is the computer aided design drawing for concept design 1. So this design uses a solid brick light frame which is hollow in the middle, and it is connected to the buoyant underneath the frame. And this design uses Ferris wheel type turbine connected to a 12 volt DC generator by using belt connector. So next, this is my detailed drawing of my design with the scale.
For concept design 2, as you can see, this design uses a floating type of frame, which is option 4, and uses option 1 turbine, uses 24 volt DC generator, uses a charge controller, uses belt connector, and uses ball bearing. Now, as you can see, Concept Design 2 uses a flat frame with two hollow tubes for buoyancy and with the ability to float. The turbine is a screw type turbine which is connected to a 24 volt DC generator by belt connector. The turbine is held in position by brackets which are connected to a bearing. This design uses a charge controller which is PWM 12 to 24 volts.
Okay. In this slide, we can see the early sketch for Concept Design 3. Design 3 is use a fixed frame design with 4 side and flat plane on top. It uses a propeller type turbine which is connected to a DC generator by belt connector. This design use a DC to DC step up modular. Okay, for next this slide, we can see all item we use in Concept Design 3 and also all measurement in any item.
Next is the product tree for the portable mini drainage hydro station. It has three main components, that is frame, turbine and electrical controller module. So frame is consumed of bracket, bearing and buoyant. So in the bearing we have ball bearing, and buoyant it has drag reduction cone. So for the turbine we have a screw type turbine, and for the electrical controller module it will connect it to the component and the wire connector.
For the bill of material, there are 8 parts. First one being the frame, which is made out of metal. 2, we are using 2 cones which are called drag reduction cones because of their streamlined shape, which is made out of PVC. Then we have a screw turbine, which is also made out of a PVC. The 4th one, we have an electric DC generator. For 5th, we have belt connector, which is made out of rubber. Then we have a electric circuit controller module. Then we have 2 brackets which are made out of metal, and then bearing, which you're going to use ball bearing, which is made out of metal as well. Now for estimated cost, we have 19 items in total. For the first one being PVC pipes, which will be used to make the turbine, which costs RM40. Then PVC pipes, which we will be used for the drag reduction cones, which cost RM10. Then PVC pipes with cover for our buoyants or the floats, which are RM20. Then the DC 24 volt generator, which is RM120. Our electric wires are estimated at a cost of RM3. Then arc welding rods at RM20 for whole set. Then hot glue sticks, which is at RM3. Epoxy glue, which is a type of industrial grade glue, which is pretty strong, at RM10. We have test span at RM8 to ensure all our circuit are working correctly, and if we need to do any minor maintenance. Our digital multimeter at RM25, Phillips screw and hex nut set at RM8, charge controller module, which is at RM40, our bearings, which are 50 mm, which are bigger compared to everyday bearings, which we commonly see, at RM20, steel rod and cable at RM40, penetrant test kit to test our weldings and project at RM20, the belt, which is our connector, RM15. Then we need a heater gun to shape the PVC at RM20. Then a belt gear set, which will be connected, one to the turbine and one more to the generator at RM20, and PVC saw to cut our PVC pipes at RM30. So the total cost of our project. An estimated total cost is RM 472 ringgit Malaysia.
So this is our block diagram for the project. There is portable mini drainage hydro station. So for the buoyant, it will connect it to the frame underneath the frame, and then the turbine, it will rotate and rotate the belt connector, and then the belt will rotate the electric DC generator, and then it will charge the controller module.
Okay, now I will explain about Sarvess fabrication. First one is shaping of a PVC for a turbine. PVC pipe will be cut off using a PVC to get a exact length needed. To cut out a PVC pipe will be then be cut across to make it into a PVC sheet shape. The sheet will be flattened using a heater gun to make it straight. Circle of exact diameter will be drawn to be cut out and shaped again using a heater gun to make it into a slight curve as the shape of the pipe. Second is connecting the PVC pipe part. The shaped PVC pipe will need to be connected or glued so it helps and position perfectly. This will be done by using hot glue gun and epoxy glue for add strength and stability. Okay. Third is cutting the metal bracket. The metal bracket will be cut according the exact size using the angle grinder and handle cutter. The grinder use blade made of various materials such as a ferron blade and diamond blade. This blade will be mounted to the grinder and rotate at a very high speed in order to cut in the desired metal. 4 is welding the bracket to the frame body. Welding is fabrication process where two or more parts are fused together by means of heat, pressure, or both forming a joint as the part cool. Welding is usually used on metal and thermoplastic, but can also be used on wood. The completely weld joint may be referred to a weldment. The bracket that holds the bearing will be welded to the frame of the project to ensure stability and holding strength of the turbine.
Next is the suggested testing. First of all, we are doing buoyancy tests. There are cylindrical cones used in the frame of the project which serve as float to keep the project afloat. And buoyancy is the outward force of a fluid on an object that is immersed. So to put it simply, the more buoyant an object is, the more likely it floats in a fluid. Buoyancy is related to density of material, and you can think of density as how tightly packed the molecules are inside an object. If an object is denser than water, it will tend to sink. If it is less denser, it will tend to float. So the cylindrical buoyant or float will be tested in a container filled with water big enough to fit the cylindrical buoyant. So the test will be done to determine if the buoyant is able to stay afloat or just sink. We also have several other tests such as device running tests, electrical production tests, and also safety tests.
As a product planned, designed and constructed, it must be tested before being product, market or present. Testing is an essential part of the developing a quality product. It has a manufacturer create products that are reliable within certain technical standard. In other words, testing is a necessary step for a product development. The frame and most part will be welded or joined using industry grade glue. This will be tested using non-destructive testing method, which is a liquid penetrant. Liquid penetrant examination is one of the most popular non-destructive examination NDE method in the industry. It is economic, versatile, and requirement minimal training when compared to the other NDE method. Liquid penetrant exam check for a material flow open to the surface by flowing very thin liquid into the flow and drawing the liquid out with a crack-like developer. Well, the most common item inspected, but plate, bar, pipe, casting, and forging are also commonly inspected using liquid penetrant examination.
For our detailed drawing and specification, we have decided to go with concept design number 2 as our final design. Now, as you can see here, there is a frame, then the drag reduction cones, we have screw turbine, the electric DC generator, the belt connector, the electric circuit controller module, the brackets, and the bearing. So let's start with the turbine, which has a total diameter of 400 mm and the total length of 1 meter, so it's 1000 mm. Next, we look at the frame, which has a width of 1300 mm and the length of 1000 mm. The two buoyants are 300 meters at diameter each, and the sheet, the top part of the frame, has a total width of 40 mm, which is 4 cm. Next, we move on to the electric DC generator. This is a rough estimation of a DC generator, which has the width of a 200 mm and length of 100 mm. Now, the belt connectors are 500 mm and 20 mm at width. The drag reduction cones are also 300 mm in diameter and 150 mm in height. The brackets are 320 mm in length and 20 mm in width. Next, the bearings have an internal diameter of 50 mm and an external diameter of 70 mm. And that's it for the detailed drawing specification. Next is the schematic circuit diagram, as you can see here. This is a schematic circuit diagram of the charge controller module. Now, moving to the Pew chart. Pew chart, we have criteria and design. Criteria's turbine effectiveness at 5 points. The weightage is 5. Durability with a weightage of 3. Mobility and portability with a weightage of 3 again. Ability to float at weightage 2. Electrical and environmental safety is an important criteria, so it is weight at 3. Now we have design 1, design 2, and design 3. So design 1 with a turbine effectiveness is a plus. With durability is a plus. Mobility and portability is a minus. The ability to float is a plus, and electrical and environmental safety is negative. So we have a total of plus 10 and negative 6, which gives out the total score of 4. For second design, we have a turbine effectiveness which is plus, durability is a plus, mobility is a plus, ability to float is an advantage, which is a plus, and electrical and environmental safety is a plus, which means it is safe for our project electricity and the environment, which in total gives plus 16 and 0 negative, and total is 16 marks. For concept design 3, turbine effectiveness is a negative, durability is a positive, mobility and portability is a positive, ability to float is a negative, electrical and environmental safety is a plus. So in total we have +9 and -7, which is -2 in total. Hence, in ranking order, concept design 2 is number 1, concept design 1 is number 2, and concept design 3 is number 3. And concept design 2 has the highest marks with at the highest ranking, hence it is selected as the final design.
Lastly, this is our Gantt chart. So all of our work of the project been done based on our planning on this Gantt chart. So that is all from us. Thank you.